Welcome everyone to this presentation. I'm Ashraful Haq from Virginia Tech, and on behalf of the authors, I'll be presenting our paper titled Quantification of Peak Demand Reduction Potential in Commercial Buildings due to HVAC Set Point and Brightness Adjustment. The paper investigates peak reduction potential of two commercial buildings within a microgrid environment through HVAC set point and brightness adjustment. For the analysis, the HVAC cooling set point has been raised from 1 degree to 5 degree at a 1 degree interval from the base case. For the brightness adjustment analysis, the brightness has been reduced from 10% to 50% at a 10% interval. The study is conducted over two different demand response periods for a winter and a summer week to understand how time of the day and different weather conditions influence buildings' peak demand reduction potential. Expected outcome of the research is the quantified load reduction potential of each building through HVAC set point and brightness adjustments. Building models are simulated in EnergyPlus and validated against monthly, daily, and 30-minute building electrical consumption with the actual consumption from the smart meter data. Therefore, a building's digital twin has been developed that has been used to do the quantification of peak demand reduction potential through HVAC set point adjustment and brightness adjustment. This slide shows the peak demand reduction through HVAC set point adjustment of Building 2. Building 2 is a triple-story building and has a surface area of about 17,000 square feet. The base case HVAC cooling set point of Building 2 is 70 degrees. The graphs show the load profiles after set point adjustments on a summer week, that is, second week of July. On the left, we see the load profiles for demand response window 1, 11 a.m. to 6 p.m. And on the right, we see the load profiles for demand response window 2 from 7 a.m. to 11 p.m. The table shows a detailed analysis of the peak demand reduction potential of Building 2 through HVAC set point adjustment. We can see that if we raise Building 2's HVAC cooling set point from the base 70 degree to 75 degree, we can reduce the peak demand from 4% to around 11%, depending on the outside temperature and building's operation condition, meaning whether the building is under operation right now or is it under the setback mode. For the setback mode, Building 2 has a cooling set point of 80 degrees. Now, coming back to the table, we can see that on July 10th, the saving is a little higher compared to the other days. That is because, as you can see in the graph on July 10th, the outside temperature is a little higher compared to the other days on the second week of July. That's why we're seeing a little bit of more peak demand reduction potential of Building 2 on that day compared to the other days. This slide shows the peak demand reduction potential of Building 2 through brightness adjustment for the second week of January. For the winter week, again, two different demand response windows have been considered. Demand response window 1 is from 7 a.m. to 10 a.m. and then again from 5 p.m. to 9 p.m. Demand response window 2 is from 7 a.m. to 11 p.m. The table shows a detailed analysis of the peak demand reduction potential of Building 2 through brightness adjustment. We can see by reducing the brightness of Building 2 by about 50%, almost 30% saving can be achieved. Results show that with the proper choice of the demand response period, along with the set point and the brightness adjustments, significant hourly peak demand reduction can be achieved for different types of commercial buildings. Further research of the topic will be on impact of occupancy and building thermal envelope on the energy consumption that is required of the building. Thank you.